2.7 billion miles from Earth, a planet has been hiding something in plain sight for over 30 years, and the James Webb Space Telescope just exposed it. Neptune's glowing auroras are not where they are supposed to be, and once you understand why, you will never look at this planet the same way again. Stay with me for the next few minutes, because this is one of those rare stories where a single image quietly rewrites something scientists thought they understood about an entire planet. By the end of this video, you will know exactly what Webb captured, why it took more than 3 decades to get a clear look at it, and why Neptune's auroras breaking the rules tells us something strange about the invisible force field wrapped around the entire planet. Let's start with why Neptune has been so difficult to study in the first place. Neptune sits so far from the sun that sunlight reaching it is roughly 900 times fainter than the sunlight we experience here on Earth. And the planet itself takes a staggering 165 years to complete a single orbit, meaning it has not even finished. One full trip around the sun since it was first discovered in 1846. The only spacecraft to ever fly directly past Neptune was NASA's Voyager 2, all the way back in 1989, giving humanity a brief, single glimpse before the spacecraft continued onward into interstellar space, never to return. That flyby was genuinely a race against time for the mission team, since Voyager 2 was already more than a decade into its journey and had to squeeze every possible measurement out of a fleeting encounter with a planet nobody would visit again for the foreseeable future. During that brief pass, Voyager 2 discovered Neptune's Great Dark Spot, a massive storm, system roughly the size of Earth, along with several new moons and a strange tilted magnetic field that puzzled scientists from the moment the data came back. Since that flyby, every image of Neptune taken from Earth or from telescopes in orbit has been limited by both the planet's enormous distance and the simple fact that most instruments are not sensitive enough to pick up the very faint infrared light Neptune actually emits. That changed the moment the James Webb Space Telescope turned its instruments toward Neptune. Using its near-infrared camera, known as NIRCam, Webb captured an image in the summer of 2022 that immediately stunned the astronomers involved. The picture delivered the clearest view of Neptune's rings in more than 30 years, since the days of that original Voyager 2 flyby. Several bright, narrow rings appeared crisply defined for the first time, alongside fainter, wispy dust bands that had barely been visible in any image, taken since 1989. Heidi Hamel, a NASA interdisciplinary scientist working on the Webb mission, described the moment plainly, saying she had been waiting for these images of Neptune for a very long time, and that she was thrilled it had finally worked. It genuinely is remarkable just how much Neptune's rings had faded from public awareness in the decades between Voyager and Webb. Unlike Saturn's famous brilliant rings, easily visible even through a small backyard telescope, Neptune's ring system is faint, dusty, and made up largely of dark, poorly reflective material, making it extraordinarily difficult to observe using visible light instruments, even ones in orbit above Earth's atmosphere. Ground-based telescopes had occasionally caught glimpses over the years, but nothing came close to the crisp clarity Webb managed on its very first attempt. Part of the reason comes down to Webb's location, positioned nearly 1 million miles from Earth, at a stable point called the second Lagrange point, far enough away and cold enough in temperature that its infrared detectors can pick up faint heat signatures without being overwhelmed by Earth's own atmospheric glow, something ground-based telescopes simply cannot avoid no matter how large their mirrors are built. Here is something that trips a lot of people up when they first see these images, so it is worth clearing up early. Neptune, in Webb's pictures, does not look blue. In fact, it often looks almost ghostly white or gray, with strange glowing streaks scattered across its surface. That is not because Webb is malfunctioning or because something has changed about the planet itself. It comes down to exactly what kind of light Webb is designed to detect. Webb's NIRCam instrument captures near-infrared light, wavelengths completely invisible to the human eye, ranging from about 0.6 to 5 microns. Neptune's iconic blue color that most of us grew up seeing in Voyager-era photographs comes from visible light being absorbed and scattered by methane gas in its atmosphere. At the infrared wavelengths Webb specializes in, that same methane gas behaves completely differently, absorbing red and infrared light so strongly that most of the planet actually appears quite dark. The bright streaks and spots that do show up represent high-altitude methane ice clouds reflecting sunlight back out before the surrounding methane gas has a chance to absorb it, essentially highlighting the tops of storm systems floating above an otherwise dim, infrared, dark planet. This is actually a broader pattern worth understanding, because it applies to nearly every Webb image released of any planet, moon, or galaxy. Color in astronomical images is almost never a literal, one-to-one representation of what a human eye would see if it floated next to the object itself. Instead, scientists typically assign visible colors to represent different wavelengths of invisible infrared light that instruments like Webb actually detect, essentially translating information the human eye could never perceive on its own into a visual format our brains can interpret and study. For Neptune specifically, the resulting composite image was built by combining several separate exposures, each one capturing a different narrow slice of infrared wavelength, then assigning artificial colors like orange, green, and blue to each individual slice so that scientists studying the image can immediately tell which features correspond to which specific wavelength of light being emitted or reflected. None of this makes the image any less real or any less scientifically valuable. It simply means the beautiful, glowing picture you see online is a carefully constructed visualization of data that would otherwise remain completely invisible to us, rather than a direct photograph in the way a phone camera captures a sunset. Look closely at the full-resolution image, and there is even more happening. A thin, faint line of brightness circles the planet's equator, something astronomers believe could be a visual signature of the deep atmospheric circulation. Patterns that power Neptune's famously violent winds, some of the fastest sustained winds recorded anywhere in the solar system. For the first time, Webb also revealed a continuous band of high-latitude clouds wrapping around a previously known vortex sitting at Neptune's south pole, giving scientists a far more complete picture of how storm systems organize themselves across the planet's turbulent atmosphere. Then there are the moons. Webb's initial Neptune image also captured 7 of the planet's 14 known moons, but one of them deserves special attention, a moon called Triton. Triton is Neptune's largest moon, and it does something almost no other large moon in the solar system does. It orbits Neptune backward in what astronomers call a retrograde orbit, moving in the opposite direction to the planet's own rotation. This unusual backward orbit has led astronomers to a genuinely fascinating theory that Triton was not originally born alongside Neptune at all, but was instead a Kuiper Belt object, one of the icy, ancient bodies, drifting in the distant, frozen edge of our solar system, that wandered too close to Neptune at some point in the ancient past and became gravitationally captured, permanently trapped in orbit around a planet it was never meant to belong to in the first place. If that capture theory holds up, and most planetary scientists consider it the leading explanation, Triton essentially represents a visitor from the solar system's ancient outer frontier, dragged in and imprisoned by Neptune-esque gravity billions of years ago, rather than forming naturally from the same disk of material that built the planet itself. That backward orbit is not just an odd trivia detail either, it actually has real physical consequences for Triton's long-term future. Because Triton orbits against the direction of Neptune's rotation, tidal forces between the two bodies are slowly, gradually pulling the moon closer to the planet with every single orbit, a process playing out over such an immense timescale that it goes essentially unnoticed on any human timescale, but which astronomers predict will eventually end with Triton being torn apart by Neptune's gravity, likely forming a spectacular new ring system sometime in the distant future, long after humanity itself will have any way of knowing whether that prediction actually came true. Triton also stands out for another reason entirely. It is one of the coldest, most geologically active moons ever observed, with active geysers erupting nitrogen gas and dark, dust-laden material from beneath its icy surface. Phenomena Voyager 2 first spotted directly during its brief 1989 flyby, making Triton one of only a handful of moons in the entire solar system confirmed to have any kind of ongoing geological activity at all. NASA and its science teams have already indicated that additional Webb observations of both Triton and Neptune are planned for the years ahead, meaning this single early image is very likely just the opening chapter of a much longer scientific story still being written. While we are on the subject of moons that may not belong to the planet they orbit, if this kind of deep, verified look into what our solar system's ice giants are actually hiding is exactly the type of content you come to this channel for, go ahead and hit that like button, and subscribe if you have not already, because the story only gets stranger from here. Now let's get to the discovery that genuinely surprised scientists, the one hiding in the title of this video. Using Webb's near-infrared spectrograph, astronomers captured something that had evaded detection for decades, clear, confirmed images of auroras glowing on Neptune. Auroras happen when energetic charged particles, usually originating from the sun, might become trapped inside a planet's magnetic field and eventually collide with the upper layers of its atmosphere, releasing the glowing light we associate with phenomena like the northern lights here on Earth. Astronomers had picked up tantalizing hints of auroral activity on Neptune before, including brief, uncertain signals detected during Voyager 2's 1989 flyby, but confirming and actually imaging that activity had remained frustratingly out of reach for more than 3 decades, even as similar auroras had already been successfully observed and photographed on Jupiter, Saturn, and Uranus. Part of the reason Neptune's auroras proved so much harder to catch than those on other gas giants comes down to a combination of distance and faintness working against astronomers at the same time. Jupiter and Saturn sit much closer to Earth, and their auroras tend to be considerably brighter, making them comparatively easier targets even for instruments with modest sensitivity. Neptune, sitting billions of miles further out and receiving vastly less solar energy to begin with, produces auroral activity so faint that only an instrument with Webb's extraordinary sensitivity to infrared light stood any realistic chance of picking it up clearly enough to confirm and photograph, rather than simply hint at through ambiguous, easily disputed data. The data, collected in June of 2023, revealed something remarkable once researchers analyzed it closely. Alongside the visible glow itself, astronomers detected an extremely prominent emission line in the spectrum, a specific signature belonging to a molecule called the trihydrogen cation, often written as H3+, a charged molecule known to form as a direct byproduct of auroral activity. Its presence gave scientists a way to both confirm the aurora was real and to measure the temperature of Neptune's upper atmosphere, the layer known as the ionosphere, directly and precisely for the first time. That temperature measurement turned out to carry its own small mystery, since researchers had expected Neptune's upper atmosphere to have cooled somewhat since Voyager's 1989 flyby, following a general pattern predicted by existing atmospheric models. Yet the new data suggested the ionosphere had remained considerably warmer than those models anticipated, adding one more small thread of genuine scientific puzzle to an already surprising set of results. Here is where the story earns its shocking billing, and it has nothing to do with aliens or anything paranormal. It has to do with geometry. On Earth, and on most planets where we have successfully observed auroras, this glowing activity concentrates near the magnetic poles, which sit reasonably close to the geographic poles most of us are familiar with from a classroom globe. Neptune breaks that pattern entirely. Its magnetic field is dramatically tilted, offset by a startling 47 degrees from the planet's actual rotational axis. And to make matters even stranger, that magnetic field is not even centered on the planet's core the way Earth's is. It is shifted dramatically off-center, closer to the equator than the poles. Because of this bizarre lopsided magnetic geometry, Neptune's auroras do not glow in neat rings around the top and bottom of the planet the way ours do. Instead, in the Webb images, the aurora appears as scattered, glowing splotches shown in cyan, positioned in locations that look, at first glance, like they simply should not be there at all if you are expecting the tidy polar rings familiar from Earth, Jupiter, or Saturn. This bizarre magnetic tilt is not actually new information on its own. Scientists have known Neptune's magnetic field was strangely skewed since Voyager 2's flyby back in 1989. What Webb's new images did was something no previous instrument had managed, directly confirming exactly where that lopsided magnetic field was funneling charged particles into the atmosphere, turning a decades-old theoretical prediction about odd, scattered auroral activity into an actual, directly observed, photographed reality. Scientists had strongly suspected Neptune's auroras would not behave like Earth's, but suspecting something and actually seeing confirmed proof of it glowing in an image are two very different things. Why does Neptune's magnetic field behave so strangely in the first place? The leading theory ties back to what Neptune and its fellow ice giant Uranus are actually made of. Unlike Jupiter and Saturn, whose magnetic fields are generated deep within cores of metallic hydrogen, behaving in fairly predictable, symmetric ways, Neptune's interior is thought to contain a slushy, electrically conductive layer of superpressurized water, ammonia, and methane, sometimes nicknamed an ocean, sitting relatively close to the planet's surface rather than buried deep at its core. Scientists believe the magnetic field is generated within this shallow, oddly shaped, conductive layer rather than from a deep, centered core, which would help explain why the resulting magnetic field ends up so lopsided and tilted compared to the neat, axis-aligned fields we see on gas giants like Jupiter and Saturn. Taken all together, what Webb actually delivered was not one single discovery, but an entire cluster of them arriving at once, the clearest ring seen in over 30 years, newly visible atmospheric circulation patterns, a confirmed continuous cloud band circling the South Pole, and now, directly imaged proof of Neptune's strange off-kilter auroras finally caught glowing exactly where its bizarre magnetic field was always predicted to push them. Every single one of these results came from a telescope sitting roughly 1 million miles from Earth, pointed at a target billions of miles further away, using nothing but the faint near-infrared light the planet happens to leak into space. There is something worth sitting with in all of this, beyond the individual scientific details. Neptune is the most distant planet in our solar system, a place so far away and so poorly studied that humanity has only ever visited it once, briefly, more than 3 decades ago, using a spacecraft that could never return for a second look. And yet, using nothing but light collected from 1 million miles away, scientists have now confirmed rings, mapped storm systems, identified a moon that may not have started life as Neptune's moon at all, and finally caught its rule-breaking auroras in the act. glowing in exactly the wrong place according to everything Earth had taught us to expect. Neptune was never actually shy about showing us these things. We simply never had an instrument sensitive enough, patient enough, or precise enough to actually look until now. If breaking down what these images genuinely reveal about our solar system's most distant planet, without the exaggeration, is exactly the kind of content you want more of, make sure you like this video and subscribe to the channel, because Webb still has years of observations left to make, and Neptune is clearly not finished surprising us yet.